So some of these things you may already know. I'm not going to spend too much time on it. Other ones I'll spend a little bit more time. So After Effects is a program used to composite 2D imagery together, has limited 3D capabilities. Basically, our purpose for After Effects is after we're done rendering our stuff out of Cinema, we'll bring it into After Effects and actually make it into a movie. We can tweak things like the coloring or the lighting or some basic lighting stuff, but we can't change any of the geometry. If something renders out over here, we want to move the geometry on the other side, we can't do that. Everything's flattened inside After Effects, okay? As you get further into it, After Effects does have some neat ways that you could actually connect Cinema right here with After Effects. So if you're working inside of After Effects, you can link right to Cinema. And if you made something in Cinema, instead of you rendering it out and then bringing it into After Effects, those two steps can work at the same time. It's a lot slower though, so we don't do that, okay? They still haven't tweaked it, so it's wonderful. Other 3D softwares use it in a very similar fashion, but that's what it's used for. Ambient occlusion is a render pass that has dark spots and light spots. So if you're looking at this, this is basically just a rendering. Here's a before and after, that's even better. So this is a rendering typically we would get, even if it has shadows inside the scene. Typically it lacks a bit of depth inside of it. So with ambient occlusion, it basically goes through and figures out like where are these surfaces like close to each other, where would you have what are called contact shadows or like occluded shadows, and that's what it generates. It generates this black and white map. Inside of After Effects, we would multiply it inside of, on top of our original one, and we would get something that has a lot more depth to it, a lot more lines. You can see here it's a lot easier to see where these are versus this. It's very difficult to see, okay? So that's something that we would actually have to turn on inside of Cinema to render out separately so that we can use. Anti-aliasing is, basically the aliasing is the edges of an image. Oops. So this is aliasing. This is anti-aliasing. So this is what a typical pixel would look like. The software goes through and figures out, okay, where are the edges? How do we soften and blend this so it looks nice? So if you've ever drawn anything and you see like a bunch of jagged lines like in Photoshop or Illustrator, typically it's not anti-aliased. It still has the edges, it still has the sharp pixels there. And so that's what anti-aliasing does. It goes through and kind of filters out or smooths it out. There's several different formulas for how they do that. For now, we're just going to stick with the default ones that I tell you in the videos, okay? Axis is just the direction that we are moving stuff in. So in Cinema, we move stuff up, down, left, right, but we can also obviously have the depth there as well. And we can rotate things around that axis and scale things around that axis. You'll find that as you get more involved in 3D, that where this is located becomes a very critical point, because how you duplicate things and rotate things is all based on, you know, that pivot point. So right now, if I put this on the ground, the pivot is right at the center. If I click here or hit L, I can drag this down. Oops, I have to click that first. There we go. Then I can drag this down to the bottom. Hit L again. And now as I scale this, it's going to scale from the bottom. It won't scale from the center. As I rotate it, it'll rotate from that point. It won't rotate from the other one, okay? So if I'm trying to create, like, let's say a clock, and I have these arms on the hand, or these arms on the clock that I want to rotate from that center point, I need to make sure it's exactly centered so that as it spins around the correct point, right? So that's what that axis is. Backface culling. We don't have to worry too much about it inside Cinema, except as a display item. So if I go here and I show my lines, you can see how I can see both the front and the back lines. If I turn on hidden lines, oops, not hidden lines. If I turn on backface culling, there it is, you'll see that we can't see the back lines. And this is a really good way for us to be able to select only what's in front of us and not what's behind us. The cube, it's pretty easy to see, but let's say that I had a sphere and I wanted to grab the points on the sphere. When I'm in this lines mode and I'm selecting stuff, let's say that I go here and I just draw a box. okay? As I spin around, you can see how it also grabbed the items right there, okay? If I say only visible items, then as I marquee this, we don't get that, okay? But we're not getting confused by this, because that's what it would look like otherwise, okay? So typically backface culling is something you'll turn on so that you don't see the back faces as you're selecting stuff in the front. Box modeling is how we modeled, how typically we start off our models with starting off from a basic cube and then adding divisions as we need to, okay? Some people will model, they'll have an object that has like 1,000,000 divisions, and then they'll start to tweak and shape and sculpt what that looks like. Unless you do it and that's the way that works for you, we're not going to do that in this class, okay? Everything should start off with a very simple shape and then add to the complexity of it. Just make life a lot easier. Even more complex shapes, like a person's face or a car or anything, typically they can start off from a cube, and just by adding divisions at the right time in the right spots, you can develop that cube, which is nicely formed and everything, okay? There's another example. There's another example. And like I said, people will even do that to cars. They'll start off with a very simple looking car, and then adding detail in areas where it needs to, you can get to that shape of having an actual like full-blown car. Bump mapping. So this is where we would get something that looks like it has bump to it or has some depth to it, but actually doesn't. So if I make a new material in here, there we go, and I render this out, you'll see that it looks nice and smooth. If I go to the bump area and I check on, let's say, noise, and then render this out again, it'll look like it has some kind of texture to it. Now this isn't done beyond where we would want it to be, but that's the gist of it, okay? There's softwares out there like Substance or Mari or Crazy Bump or all these other ones that will allow you to create bump maps. Typically a bump map is going to be something that's black and white. The software will read a gray image, okay? So wherever it's black, there's no bump. Wherever it's white, there will be a bump. There's also something called a normal map, which is further down the list. This is a RGB image of that bump, and it's usually a lot more detailed. You get a lot more information there because you're not dealing with just one value. There's actually several values that are stored in each one of the channels that it uses to create the bump. And a lot of times you'll see, if you look at a game character, oops. You can see here's the basic geometry, here's the normal map, and then that's what it looks like at the end. Like you can really create some high definition stuff. Anything. Even people, like if you have like pores on their skin and you want to have that detail come out, you can go into some softwares, paint where you want those pores to be, generate a normal map, and then utilize that. Cinema 4D, we know what that one. Mainly, it's used for doing motion graphics, which is why we use Cinema. Maya can also do motion graphics, but it doesn't do them as nicely as Cinema does. Cinema is also very quick for some dynamic stuff, so doing some very quick dynamics. Rigging in it is horrible. UV layout is horrible. For motion graphics, it's good. CMYK, cyan, magenta, yellow, and black. Everything we do on the computer, think about the output. Something we're dealing with here is typically going to be seen on screen. So we're going to deal with RGB. If we're going to print this, we would then convert it to CMYK. Okay. Direct illumination, we talked about this when we did our lighting stuff. Just having a light in the scene. This is giving it direct illumination. The light leaves the light, hits the box, and then it gets lit up. Okay, it's direct. I'll skip down to indirect illumination right here. Light bounces off of a surface. So if we were to have a wall behind this, and I remember what software I'm in and I use the right hotkeys. There we go. the light would come in, it would hit this back wall, and then it would bounce off and light this up. Okay? In 3D, that's not free. We have to add that in there. We have to tell it, yes, I want you to do that. Okay? And that process is called global illumination. Okay? So in the software, we have direct light, we have indirect light. The process of enabling this to actually be more realistic will be global illumination. Okay? Displacement. So displacement is different than bump. Let me drop this back on here. Actually, let me just make a new one. There we go. Okay, so this is smooth again. If we go down to displacement and we turn this on, and then I go to noise here, you'll see that the image for this is not just a sphere that looks like it's bumpy, it actually bumps it out. Okay, displacements will actually give you that depth. So now if we render this, and why aren't you showing up? Let me make sure I have it on the right one. Yes, this. Displacement's on. Make the height bigger. There we go. Oh, that's right. There's not enough divisions in it to actually show anything because I have a cube. Let me go to the cube. Let me add a bunch of divisions. There we go. 500 divisions in all directions. Oops. And now that's way too big. But that's what it's doing, right? It's actually bumping and distorting the surface. When you look at something that you would see like in a Hollywood movie, they would develop the color maps. They would develop specular maps, which is like the reflectivity. They would also develop translucency maps for like the skin. So if you hold a flashlight up to your skin, how you can kind of see through it. They would also develop a bump map, and they would also develop a displacement map. And all of these things packed into that are what make the models so realistic. And it takes obviously a lot of time to do that, but that's how they do it. Okay. Edge loops. This is how we've been modeling our stuff, or what we've been doing to our stuff. Let me put this back to 10. There we go. So each one of these that go around, that's an edge loop. It loops all the way around the surface. If I go to my move tool, I go to edges and I double click one, it will select an edge loop. And of course we can use the knife tool to insert more edge loops. Okay? And remember, the fact that it's going all the way around, that means that, you know, we've modeled it good. Extruding, this is just pulling faces out by extruding it like that, or extruding it inward. We could also do an extrude inner, and then extrude that way. Okay, so lots of different techniques for extruding. Fall off is just a softening of the edges. We talked about this a little bit when we did our other stuff. I'll show this on a plane so you can see it better. So let's say that I'm going to grab some points in here. And if I go here to my move tool, I could turn on soft selection. This soft selection has a fall off, okay? Lots of tools have fall offs. This is just one of them. So this fall off right now is I selected the single point, and it's gradually selecting the points around it. So that as I move that single point, it doesn't just move the single point, it moves the whole thing. Without fall off, it does that, okay? Now there's different kinds of fall off depending on how you want to do it. Right now there's linear, which is here's the start, here's the end, and it just equally distributes it. You can make it, let's say, bell or let's say spline. I'll control it this way. So this way I'm going to have a lot of control right at the start of it and very little control at the end. So as I move this up, not much is happening. Let me change the radius some. There you go. So a lot is being pulled right in the middle, and you can see how the very outside of it is moving just a little bit. If I move this graph the other way, there you go. We'll get a lot of movement over the entire thing, okay? So each tool inside of Cinema, or not each tool, but lots of tools inside Cinema will have this fall off that we can adjust and control how drastic or harsh our effect is. Fresnel is the way that light bounces off and is perceived by a surface. So if you've ever sat in traffic and you see a bright, shiny red car in front of you, if you look at the reflections of the car, you'll notice that the reflections in the front are not the same as the reflections around the side. And so that's what Fresnel is referring to. So, there we go. So if you look at this, you'll see this is a dead-on, like everything is the same amount of reflectivity. The sphere actually turns out looking very flat looking. This is with Fresnel. So you can see that the reflections are a lot sharper around the edges and then a lot more subtle in the center. They're still there, it's just a lot more subtle. Okay? Each surface has its own Fresnel number depending on what kind of reflectivity it is or refraction that's happening. But that's what it's referring to. Here's a chart with all these different Fresnel numbers. Okay. Global illumination we covered. A high dynamic range image. So when you look at there we go. When you look at stuff that's in movies, if they have a CG character walking through the scene, in order for them to make it look realistic, they would have to have the same lights that you would have in the scene. So if there's a bunch of spotlights along the side of the wall and a floor grate that's illuminating from below, those light information has to be in the 3D world in order for them to make it look that realistic. So what they do is they go to the set, and typically there's a visual effects supervisor or a production crew type person there. Capture HDR. And what they do is they take a bunch of pictures. So they'll go through, they'll set up their camera. There we go. They'll set up a camera similar to this, and they'll basically take a picture from this direction, this direction, this direction. They go all the way around 360 degrees. They tilt it up, do it again. They tilt it down, do it again. Now they're also taking different exposures. So they're going to take a super bright image, a medium image, and a super dark image. They smash all these together, that gives you an HDR. And that's basically all the lighting information from that image, okay? These are HDRs that you can get online. So if you wanted your stuff to have a more realistic looking feel to it, you could use these kinds of things. Like if I had a robot and I wanted him to look like he's in a factory, I can use this image as my lighting information for that scene, and my robot would have a much more realistic look because he's getting lighting and reflections from an actual environment. Versus 3D, which is nothing, right? We'd have to build that entire environment for him to reflect into the environment, okay? This is what an HDR would typically look like. And source images, where are you at? There you are. So this is an HDR, and they're always going to be 2 times wider than taller, just how it works out. And if I hover my mouse over this, you'll see my red, green, and blue values here. It says 0.1, 0.2, and 0.6. As I move more towards where the sun is, you'll see how this gets really bright. And it's actually extending to like 50, 847, 2000, okay? This is a 32-bit image. Lots of information is inside here, okay? And basically it's recognizing that way up there, that is 2,000 or 6,000 times brighter than it is here, okay? And then the blue of the sky, the sun that's up there, the grass, all of that is used as reflection, used as bounce light that would go into our scene. And then just so you can see what it looked like in the real world, if I put this on a sphere and I stood in the middle of it, I turned off my grid. This is where the photographer was standing when they shot this. There's the sun, and there's all that. And if you look at the sun, not in real life, but in here, and I drag this way, oops, sorry, I have to go back to this. If I drag this way, you can basically make out the sun now much more than you could when it was here. Because they've captured all this lighting information and stacked it inside this image, they have that stuff readily available. Even way over here, like you can barely see anything in those shadows, definitely in the projector, probably not at all. But then as I crank this up, now I can actually start to make out the tree's trunk itself and the detail that's on that. Okay. Now this isn't doing like a brightness or darkness on there. It's not doing that at all. Have you ever photographed someone in front of a window and basically you're going to get one or the other, right? You're either going to get the outside, whatever's out there, or you're going to get what's inside the house. If you do an HDR of this, you take one picture where the inside looks good, one picture where the outside looks good, and then you can put those two images together and actually get both things, okay? So that's what essentially it's doing, just with a lot more images. So we'll use this for lighting information. When we get to our product, we'll really see that, because our product and our drone will be using those. HSV, this is a different way to select colors than you might be used to, and for me, it's my preferred method. So anytime I pick colors, I use HSV sliders. If you've used Photoshop, you've probably seen the RGB ones, right? Or you may have seen, I don't know what that one is, palettes, obviously. The HSV is like perfect. Here's the hue, here's the saturation, and then here's the value. It's really easy to use if you just like, I want something blue. There it is. And then I want less saturation, and I want it to be darker. Really easy to move around and change different colors like that. An IES light is a light that's used to, again, simulate real-world stuff. So you might have something like a, if I can spell architectural, 3D, interior, there we go. So this is a 3D rendering of a living room, okay? Much more pumped up than ours is. If you look at any of the lights that are in actual 3D, like the default ones that we drop on, they're pretty disgusting looking because it's just like a light and then it just like shines forever and it's just like unnatural. So IES profiles are created by lighting manufacturers. And basically what they allow you to do is take your boring light and assign an image to it so that the light would then look like one of these. Okay? And each one of those is a different profile. So if I'm doing something like this architectural render and I want these lights to look more natural, more realistic, I would find which one of these I like best and then use that for my light for each one of those. Mm-hmm.
So is it an actual light or just an image of a light?
It's a definition of a light. Let's put it that way. So instead of our light having intensity forever, imagine that it just has super intensity here and then it gradually drops off gradually drops off a little bit and then really quick drops off. Okay? And each one is kind of different as to how they're set up. It's not a picture, so we wouldn't be able to see the picture. But they have them for like everything. I'm trying to find a better one. Not so much that, not so much that. There you go. So there's another one in the back there. Okay? And what's cool about it is the light would then have an actual direction and not just shine every direction. And these are free, so you can go and download these and utilize them. They're pretty awesome. Index of refraction is how much light bends when you have refraction. When you have glass, okay? So if you're not familiar with how lighting works when it comes to glass, the light hits the glass, it bends, it hits the other side of the glass and bends again, okay? Like this. The light hits the glass and then it bends, and if there was another piece of glass there, it would bend again. There you go. Bending. Hits the glass, bends, hits the glass, bends again. Okay? So how much it bends, that's the index of refraction. And each item has a different value. Glass, emeralds, water, everything like that has different values that they would utilize. So if I had a sphere and it had this material on it, and I went to my transparency and I told it that this is glass, the main thing that is changing here is this number. What is that index of refraction? If this is water, it changes that to 1.33. Okay? Each item, like I said, is going to have a different number. Index of refraction. And those numbers are actually on Wikipedia. You can find, or whatever that is. No, they don't have one. you go. Here's an actual chart of what each number is. So diamond is 2.42, sapphire is 1.77, ice is 1.31, and so on. There's water right there. So usually I'll use it as a starting point. With the drop-ins here, it's great that they have those. Some software don't. And so you basically have to like start off from nothing and then go from there. So here's beer, right? That's a drop-in. So typically you start off with that and then you can tweak it from there. Indirect illumination we went over. Interpolation is just how we change from one item to another. So if we have two keyframes, how are we getting from one keyframe to the other keyframe? Typically, I'll just set a very simple keyframe here and just go sphere, coordinates, there, okay. And then I'm going to right click on this and go to show F curve. You can see that, okay. So right now this is doing an ease in and ease out. So it's like a spline interpolation. If I change this to linear, now it's a linear interpolation. If I change it to step, now it's a step interpolation. And all step means is that it's just going to jump. So here it's going to be the same value, same value, same value. When it gets to the keyframe, it jumps. When I change it to linear, it's going to gradually move from one spot to the next, all evenly spaced. When I have it at the default one, it will pick up speed, go fast, and then slow down. Okay? So when you look at any interpolation, that's what it's referring to. Keyframes, you set keyframes to animate stuff. You can't animate something without a keyframe or something controlling it. Keyshot is a separate program. Eventually we will use Keyshot. When you want your stuff to be rendered quickly-ish, you use Keyshot. And what this is more of a rendering-only environment. I bring my models in here, I can drop materials on there, I can change lighting, I can change my HDR, and really quickly it'll update all the stuff. If I wanted this to be like a red chrome, I can go in here, find red chrome, drop it on, boom, it's red chrome. I can tweak the settings if I need to. A lot of companies will use that for product rendering, so they'll have someone in another software model the product, they'll bring it into Keyshot, and then they'll spend another week or two in here tweaking it and getting it just so. Once they have this, then they can just save out another iteration, change this to red, save out another iteration, change it to yellow. Now they have several different versions of that same item, okay? Lathe or revolve. As we start modeling stuff, we'll find different methods to model things. One of those is going to be to utilize curves, okay? Has anyone here used CAD before? Okay. So in CAD, there's a lot of curves and lines that you draw inside the software. Here, you can do that, and then you can take those and actually make them into 3D items. So if I go to my pen tool and I switch to, let's say, this view, yep. And I just kind of draw a shape, that's wonderful. And then I get out of the shape, there it is. So now underneath here, there's a lathe, sweep, extrude, and loft. So I'm going to go to lathe first. Lathe/revolve, some softwares call it revolve, some call it lathe. I drop spline into lathe, and I get a piece of geometry. Okay, it takes that curve, and it just spins it around, and there we go. So if you can find a shape that is that same profile all the way around, you can utilize that. For this water bottle, I may have, to open it up, I may have one shape for the main area here. I may have another shape for the base top, and then use those as starting points for how I model the rest of it. Where the hinge is, where the flip top is, where the screw part is, those all may be separate pieces I add on top of it. But that's a good way to start it off versus having to start off with a cube. While we're in here, let's talk about the other ones. So that's lathe. Each one of these, if you look close, you'll see a white line that tells you how many curves you need to do that one. So I'm going to do extrude next because that's the only other one that needs one. Drop this in. And if I go to the options for this, it makes it a little bit easier to see. Oops, and I go the correct direction. There we go. So this will basically take that curve and just go straight with it. Okay. You can put a cap on it. Oops, I didn't close it, so I can't put a cap on this one. Let me close it so I can put a cap on. Create spline, pen. There we go. All right, let's go back to extrude. There we go. So now we have a cap on there, or we can take the cap off of there. So again, a kind of quick way to be able to create a surface instead of trying to model out of something, you can draw that shape. Think of like a guitar body. You have that very distinct kind of curvy shape to that main part of it. You could draw that out and then extrude it. You could also bring stuff in from Illustrator. So if you drew your curves in Illustrator, you can bring those in here. It's stupid. It's called merge objects. It's not like import, which what you think it would. So you would merge, find your Illustrator drawing, and there you go, sir.
Never mind, you answered my question with the Illustrator.
Okay. Yeah. Sometimes drawing in here is not it's not easy to do if you're not used to it. Take some time to get used to it, but yeah. All right. So that's that one. Oops. What else do we have? We have sweep, and we have loft. Okay. So for these ones, I'm just going to use the defaults here. So I'm going to use a circle. And then I'll use, let's say, a star. So less points. Make this bigger. Make this smaller. There we go. All right. So for sweep, we need two curves. I'm going to take these two curves, drop them into sweep. We get that. Depending on which one is on top, you will get different results. So let me drop that back in. I'm going to take circle and drop that back on sweep so it puts it on top. And now we get that. Okay, what it's doing is it's taking that circle and it's basically sweeping it along that other curve. So as one curve goes like a triangle, it's doing that. Now because of how we set up our stuff, I can go back to my points and I can add more points. I can go back to my circle, I can take away points. Let's make natural. And so now we have more of a sharp-edged item. Ring. I can change the radius of it. There we go. Cool. So now let me take star and we'll scoot that down. We'll delete sweep. All right, so now for loft, we need multiple curves, so I'll just duplicate this and duplicate that. I'm going to take all three of these and drop it in. So what this is going to do is it's going to connect one curve to the next curve to the next curve. Okay, so like extrude will just go straight. The one we were just on sweep will kind of follow that other curve, but sometimes I want to have just multiple curves and just tweak them from there. So if I grab one of my curves and move it, you can see how it moves that shape. You can also see that it's kind of like overlapping itself. Depending on the order we have here, that's the order it's going to go in. So this one is at the end. That should be at the end in here. There we go. So it should go this one, then that one, then that one. And then as I start to move these, I can really start to customize what this shape looks like. So if I wanted something that, you know, looks like that, right, like a Twizzler, gramophone, right? So lots of different ways you can use those as starting points for creating the next stages of your model. All of these have their own options. So like Loft has its settings right here. So how many subdivisions we have. It also has the caps, obviously. We can play with those. Yeah, that's pretty much all we need to discuss on that part right now. Okay, so they all have the same type of setup. Layers, a good way to keep us organized, making sure our stuff is on layers. Mari is a software program that we can do texture painting. So inside here, you would actually go through, and if you wanted to paint the goggles blue or green or red, you go with like Photoshop brushes and you paint right on top of the model. You could also grab pictures, so when they do something like this, they're actually bringing in an image of scales and then painting those image of scales right on the person, okay? Same thing there, and there, and there. So like for that wood, they have a picture of wood, they painted that picture of wood on there, kind of like rubber stamping or cloning. Maya is another 3D software. It's very similar. Once you know Cinema, that's the software we're using, those skills will translate into any other 3D software, even if it's not Maya or Cinema or 3D Studio Max or one of those. So this is what Maya's interface looks like. I'm not going to open it up on mine, but just so you can see it. Very similar stuff. Here's your objects, here's attributes, there's your modeling thing. All the same techniques are going to flow from one software to the other. Same way you model in Maya, same way you model in Cinema. Tools are just in different spots, that's all. Mesh is just another name for polygon object. So sometimes you'll hear people refer to it as a polygon, sometimes a mesh, sometimes a polymesh, sometimes a combination of those. Mudbox or ZBrush are sculpting programs. So when you see this guy here, he could have been completed entirely inside Maya. When you see something with this much detail, typically that's going to be done inside of ZBrush or Mudbox. Imagine instead of us extruding things and adding divisions and whatever else, we had 1,000,000 divisions and we're just pushing and pulling and sculpting more like clay inside here. So that's what ZBrush and Mudbox are good for. And you can also do texture painting, you can do hair, you can do a whole lot of stuff inside that software. It's pretty awesome. Like on this one, yeah, it's hard for you to see, I'm sure. Yeah, right there, this is how many polygons are in there. There are 16 million polygons in this scene. If we tried to have 1 million inside Cinema, it would probably crash, just for fun. Let's say 10,000 divisions by 10,000 divisions by 10,000 divisions. Nope, it only goes to 1,000 by 1,000. And you can see how slow this is going already. I scaled it, I'm waiting now. I didn't do anything. There we go. Now, ZBrush and Mudbox, no problem. You can go in there and push and pull and tweak and scale and do all this stuff. There's no limit to how fast it's going to go. When you're at this resolution, it still goes pretty quick. So a lot of times you'll see some high detailed renderings, and those are typically going to be something that they've done inside of ZBrush or Mudbox. There you go. You can see all that skin pore detail that's right inside there. There's no way to get that right inside of Cinema, right inside of Maya. All of that has been actually sculpted onto the surface. And he's at 50 million polygons for the whole character. Lots of stuff there. A node is just a generic container which can hold any kind of information. So typically Cinema has, not this version. No, it's the next version. Cinema 20 has a node graph editor. But these are what nodes are. Just I'm storing information here, and I'm storing information here, and storing information there. As I connect these together, I can change what the end result is going to look like. So with this grade node on here, if I go over this and I go like that, you can see how I'm changing the color of that image, okay? The cool thing about a node-based workflow, which is a lot of softwares are going towards this method, is that if I come up with a brand new image, I just delete this one or reload my new one in and everything else happens. I don't have to go back and redo it. Imagine Photoshop, you open up a picture, you crop it, you adjust the colors, you do this, that, whatever, and then the image changes. You have to start all over again and do it all over to that. Here, I just change that and it's all done. And so you can create some very cool things when you get a node-based workflow going. once it's open, you'll see. There we go. So this is a 3D item. So this was done inside Maya. I rendered out a left camera and a right camera. I brought it into Nuke, and I put them together so that I would have this, which if you put the glasses on for 3D, the water wheel would look like it's actually like 3D, like floating in space. Once this is set up, if I decided that I had a new project I want to do this with, I change the right camera, I change the left camera. Everything else I've done, it just automatically updates. Okay? So nodes are where the industry is really going with a lot of their stuff. So don't be surprised when you see Photoshop and Illustrator and After Effects starting to have more of this kind of stuff in there. Non-linear way of animating is allowing you to manipulate stuff at any point in time. If you did sketches, like you did a flip book, you draw frame 1, you draw frame 2, you draw frame 3. That's linear, 1, 2, 3, 4, and so on. Non-linear, we can go to frame 1, we can go to frame 50, we can go to 25, we can go to 18, we can just bounce all over the place. So it doesn't matter where we're at. That's the kind of animation we do in digital stuff. A normal is a line perpendicular to the center of the surface. So if I go in here, normals, oops, let me delete this huge one. Even deleting it's taking a long time. There it goes. I go there, and I go to options. It should be showing up. I don't know, something's set that's not working. Mesh. So a normal is basically this. Every surface inside of 3D has a top and a bottom. Okay? If you have a plane, the plane still has a top and it still has a bottom. The normals tell you which direction is the top. Okay? Typically in the stuff we're doing here, we don't need to worry about it too much. When we start moving to other softwares, then we have to worry about it. Sometimes in cinema we have to, depending on what we've done, but typically we don't. And you'll see what happens. But yeah, this is showing you all of these are nice. And then these ones, because they're not facing the correct direction, are not nice. Nuke is a software used to composite 3D and 2D. So that's the software I keep popping up here. Anything that's a movie, they've used Nuke for. Okay? And this is where they're doing all their visual effects. They take all their stuff from 3D, their stuff from 2D, they put it together inside Nuke, and then they'll do whatever they do here and then send it out. It's a super powerful software. There's so much stuff you can do in it. You can see all the stuff. If you watch District 9, on YouTube, there's actually like District 9 videos where they go through like, here's all the stuff we did in Nuke inside District 9. You can actually bring in 3D geometry into Nuke. You can relight stuff in Nuke. There's a whole mess of things you can do inside there. And again, all node graph stuff. A null is just an empty object. There we go. So if I don't have anything selected and I just group, I can't group. If I just go to create null, this is just a nothing object. Basically, if I call this whatever, there you go, I can drop my cube in it, and now if I grab the whatever item, I can move that whatever item around. If I had 20 items, I wanted to move all those items together, I could make a null and drop them in there, or I could just grab them all and group them. It's the same exact thing. Okay? Sometimes you'll have nulls for controlling different items like rigging and whatnot. A pass or render pass. Whenever you look at, again, stuff that you see inside of movies, there we go, okay? So this is my regular render, basically what we got out of it. But inside here I have several passes. One of them is an ambient occlusion pass. So if you remember from the first part of the definitions, we talked about ambient occlusion. There's that pass. It's stored inside of that file. There's also an alpha channel. This is a different pass. There's a direct illumination pass. There's an indirect illumination pass. There's a shadow pass. There's the shadow. And there's a specular pass, and where's my depth? There's a depth pass. If I crank this down, you can actually see, maybe. It's still like crazy there. There it is. Okay, and then all of these passes are storing information for me to use later on. This one specifically is storing how far from the camera is each one of my items. So as I hover my mouse over these areas, if you watch down here, you'll see that number change. And that's how far in pixels, or in centimeters, it is from my camera. Okay, so this is 66, and as I get to the background, it's 420. As you get really far, it's 9,999. And then I can use that. Oops. And we'll reset this. I can use that information to actually make the background blur. So if I go here and I set this to direct, and then I move this focal point, I say this is what's in focus, you'll see that that item right there is crystal clear in focus, and then it gradually blurs out. Then I can add this here. There we go. So now that's pretty much in focus, and then way back in the distance, that's completely out of focus.
How does it know how far it is?
It actually uses the camera data to figure that stuff out. So when it renders, it basically goes through and says, well, how far, this pixel, how far is it from the camera? How far is this one? And then it's able to do that.
So it uses the depth information.
Yep. Cool. Photoshop, we know what Photoshop is. We can use it, in this case, for creating textures or paintings, manipulating or enhancing images. Everything you get out of cinema, think about how can I make this better? Okay, sometimes it's After Effects, sometimes it's Photoshop. If it's a video, After Effects. If it's an image, Photoshop. Physical rendering is where we try to simulate stuff as close as possible to the real world. So trying to use realistic lights, realistic scale of our scene, realistic dynamics if we have that. Everything in the scene is as realistic as we can get it. When they look at a movie and they have basically like Iron Man. Iron Man is Tony Stark in this scene, and then 2 seconds later it's a digital version of him. In order for that to look accurate, they have to build the entire scene as accurately as possible, build him as accurately as possible, light it, textures, everything, so that they both match. Otherwise it would look like it did 20 years ago. A quad is a four-sided polygon. So 4 sides. There we go. 1, 2, 3, 4. Let me turn that off. 2, 3, 4. Okay. If I split it using my knife tool, there we go. This right here is no longer 4 sides. 1, 2, 3, 4, and 5. And now this one creates a triangle. 1, 2, 3. Triangles are bad. Anything not a quad is bad. If we can get quads, we should definitely strive to have everything as a quad. It makes the world a happier place. Rendering is just the method of taking 3D objects, lights, materials, and making it into a flattened out image that we can show mom and dad. RGB is red, green, blue. Sampling is the way that it refines stuff. So when we look at our lights hit an object and then there's shadows, it's all digital, so it's not like a real light, it's not like real shadows. When it looks at the lights and the objects and the shadows and the ground and all that, there's sampling is what kind of figures out how detailed we need to get in those shadow areas or reflection areas or any of those. The more samples we have, the more detailed it is, or the longer it's going to take and the more detailed it can be. You'll hit a point where it just doesn't do anymore. Oops. When we look at our render settings here, and we go to anti-aliasing, here's our samples 1 by 1, and then 4 by 4 is the highest that we have. As we crank this up to 16 by 16, it's basically going to go even more in depth in each area to verify that everything is nice and smooth like it should be. Okay? The lower these settings are, the quicker it's just trying to figure out what things should look like. The higher the samples, the more detail. Snapping is a way for us to snap our items and objects to the grid, to objects, to whatever. We'll get more into those when we do the hotkeys, you'll see. Subsurface scattering is the light that enters. Why isn't that going to the right window? There you go. Is more like skin. So this is subsurface scattering, and that's a different kind of shading technique. It's not just like if I want a person to look right, I'll go to the color swatch and pick that color of the skin. You have to go through and set up what does the skin look like, how thick is the skin, what does the inside of it look like, and then you have to have your light set up correctly so that you would get the effect like this, or like that, or like that. Okay? And usually that's going to involve maps, texture maps for all this stuff. If you watch, you can kind of see it in this one a little bit, but if you watch Star Wars, like Yoda's ears are green, and then you can even see like veins going through them. That's actually a texture map that says there's a vein right there. It's pretty sweet. Texture maps, just images we would use to make things look right. We want veins on Yoda's ears. We need a texture map or picture of veins that we can put on Yoda's ears. Some softwares we can paint in, so like Mari Substance. Even has body paint. These tabs here, 3D paint and UV edit. Topology just means how all your faces are laying out on your surface. There's something called good topology. Weed. That's what came up first. Good versus bad weed. So here's bad topology. You can see how the edges are just kind of like jagged. It's messy. Nice and clean, this is good. Okay? This is easier to work with. We'll create a nicer, smoother model than something like that. Triangle we talked about. Unreal is a 3D gaming engine. Anything we build in 3D, we can take into a gaming engine and actually make it interactive. So this water wheel here, I can actually export that out, bring it into a gaming engine, and have that as a prop. Once you know the workflow and you have it set up, it literally is just like export, bring it in, there it is. And it's a pretty quick flow from one to the other. Unreal is also free, so if you do want to download it and play with it and start importing your models, you can do that. Vertex or points or vertices is just that. The little points right here, that's a vertex or vertice. And then ZDepth, which is our last thing, is just that render pass, which records the information from the camera to our subject. And you typically want to do these for your renders if you want it to look realistic. And think of it too like if you're doing a mask, like this is a good example. Let's say I wanted to desaturate my forest scene here. So I rendered out my regular forest scene. Everything is pretty vibrant from the very, very back to the very, very front. But what do you know about environments the further off you go? You can't see it, and it's pretty desaturated back there. Like way in the distance, it's like you don't see any color. So you can use this as a mask on top of saturation, on top of brightness, to actually control what it looks like. So even though I'm using, oops, that's still like that. Let me go here. Even though I was using this to control the focus of it, I could also pull this out, and don't pay attention to specifically what I'm doing here. Grade. I need to bring it into a range I can actually see. There we go. And then let's say I did a saturation on this, and I'm just going to desaturate the whole thing. Well, I don't want the whole thing desaturated, so I'm going to drag a mask here. Nope, here. And then still tweak this a little bit more. There you go. Let's see how that looks. All right, I'm going to invert it because this is already, actually, let me just color it here. This is gray, so gray desaturated is basically gray. Go to that. There we go. So now it's red. So now when I desaturate this, still turn that. Mask, oh, that's why. There we go. Ignore that line, that's just from other stuff. But you see way in the back, that's gray, and then here we have color. And then as I take that saturation, I can bring it back up or bring it down. And I'm only affecting the background, I'm not affecting the main area. Okay, so you can use a lot with these passes. The more comfortable you get with them, the better off. You know, you'll be able to tweak and modify what your end product looks like. Some of those scripts get really, really long. These are all called scripts inside of Nuke. So here is that same one, and then here it is at the end. And you can see there's a huge difference. And the before and after. The colors are adjusted, there's depth of field on it, there's some glows. And all that was done using passes. Every single one of these areas, this is a pass, this is a pass, this is a pass, that's a pass. These are all passes. There's my background glow, my vignette, and so on. Okay, you don't have to go complicated like Nuke, but just Photoshop. Just learn some basic Photoshop for doing that kind of stuff. Cool. Any questions on the definitions? Okay, so when you come